Hello class, Dr. Bans here. Let's take a look at these two sequences, I and II. Let's find their respective Z transforms and then ROCs. Okay, so let's begin with the very first one. Okay, so here we have I. X of n is equals to A exponent n into U of what? N. Okay, so first, let's plot this unit step sequence. Okay, where is the unit step sequence? This one, U of what? N is a unit step sequence. Okay, so U of N is equals to what? Unit step sequence. Unit step sequence. Okay, U of N is a unit step what? Sequence. Alright, so let's plot the unit step sequence. So if we plot this unit step sequence, this is what we have. Okay, this is what we have. Okay, here is U of what? N. Okay, and then U of N means that N is equals to what? 0. So the sequence will start from what? 0. Okay, it will start from 0. Alright, 0. Okay, it will start from 0. So here is what? 1, 2, 3, and 4. And then it will go to what? Infinity. So it will go to what? Infinity. Okay, here is what? 0. Okay, so that means that our sequence is starting from 0 and then it's going to what? Infinity. That's how our sequence is behaving. So now let's put down the general formula for what? Z transform, which is what? Summation of n is equals to minus infinity to what? Infinity. X of n into z exponent minus what? N. Okay, now let me include my sequence. Okay, so if I include my sequence, then my x of what? Z now becomes summation what? N is equals to 0 because the sequence is starting from 0 and it's going to infinity. And here becomes what? Infinity. And my x of n, what is my x of n? A exponent what? N into u of what? N. So A exponent n into u of what? N into what? Z minus n. Z minus n. But this sequence, the magnitude here is what? 1. Okay. That means that u of n is equals to what? 1. So where I have u of n, I can put 1 over there. Okay, so if I put 1 over there, then my x of what? Z is now equals to infinity. N is equals to what? 0. Okay, A exponent n. If I put 1 here, then this place will become like this. Okay, so that is how it will become. Okay, so now what I can do is that I can actually simplify this particular equation by writing it this way. N is equals to what? 0, and then here is what? Infinity. Okay, I can have here to be A exponent minus what? 1. Okay, and then I'll bring what? N here. Okay, it's the same because if you multiply n by a, you get a exponent n as it is here. If you multiply n by z minus 1, you get n exponent minus what? You get z exponent what? Minus n, which is the same as here. Okay, so the equations are the same. Okay, so now what I can do from here is to what? Is to make sure that I expand this equation. How do I expand this equation? By putting in the values of what? N. N is equals to 0, n is equals to 1, n is equals to 2, n is equals to 3. I must up to what? Infinity. Okay, so I must put those values into this equation. Okay, so first to begin with, x of what? Z is equals to n is equals to 0. If I put 0 into this equation, what do I get? Here becomes what? 0. Any number exponent 0 is what? 1. So I'll get 1 because any number exponent what? 0 is 1. So if n is equal to 0, then this place is 0. So it will be 1. Then I'll put 1 into the equation. If I put 1 into this equation, I'll get this one. So I'll get a z minus 1. If I put 2 into the equation, what will I get? Okay, if I put 2 into the equation, I'll get what? A z minus what? 1. And this place becomes what? 2. If I put 3 into the equation, I'll get what? A z minus what? 1. And this place becomes what? 3. Okay, it will continue up to what? Infinity. It will continue up to infinity. So now let me say that, let's say that let a z minus 1 is to be equals to what? X. Okay, let a z minus 1 to be equals to z. So now if I have that one, then what I'll have is that x of what? z will now be equals to what? 1 plus what? X plus what? S squared plus what? S cubed up to what? Infinity. Up to infinity. And then according to binomial expansion, whenever you have any expansion, any series, okay, or any sequence of this particular format, okay, in binomial expansion, it is here x of what? Z. This series, okay, this expansion is 1 minus what? X exponent minus 1, okay. So this is the binomial expansion that gives this particular series of 1 plus what? X plus what? S squared plus what? S cubed plus what? Up to what? Infinity. Okay, so that is how you can get this one. Okay, so now that is my actually my Z transform for this particular series. So now I can see that my Z transform is equals to this one, okay, is equals to what? 1 minus x exponent minus what? 1, okay, which is equals to 1 over x, 1 over what? 1 over 1. Sorry, 1 over what? 1 over 1 minus what? X, okay, 1 over what? 1 minus x. Okay, so this becomes what? My Z transform. But I know that this is equals to what? 1 over what? 1 minus what? AZ minus 1. Why? Because I said that let x to be equals to what? This one. Okay. Alright. So now basically, if I should multiply through this sequence, okay, by z, if I should multiply through by z, then I'm going to get z over what? Z minus what? Minus a. Okay, so this is going to be my what? My z transform. This is going to be my z transform for this equation. Okay, so now having gotten the z transform, let me find the what? ROC. Okay, so the ROC. Okay, so the ROC is such that the summation of n from minus infinity to infinity, okay, this particular summation should be less than what? Infinity. Okay, that means that the summation should converge before it will get to what? Infinity. It shouldn't get to infinity. It should always converge. The summation should always be less than what? Infinity. It should converge before infinity. Now, if you look at this particular series, whenever n is greater than 1, that means that it will never converge because this summation is going to what? Infinity. So for this summation to converge from mathematical principles, x should not be what? Greater than 1. Okay, if x is greater than 1, like if you take 2, 3, 4, then it's going to continue until what? Infinity. But before it can converge, x should be less than what? 1. Okay, x should be less than 1. Okay, before it can converge. So I'll say that ROC, okay, ROC, okay, x should be what? Less than what? 1 before, so that it can what? Converge. So that it can converge, okay, so that it can converge. So, but I also know that this x basically is what? Is the same thing as what? AZ minus what? 1. So I'll write AZ minus what? 1 should be less than what? 1. Okay, so this will give me A over what? Z should be less than what? 1. So now this one will give me A less than what? Z, okay, or it will give me Z greater than, okay, A, okay, Z greater than what? A, okay, or it will give me this one. All right, now having known this one, let's plot our what? Z transform. Okay, let's plot our Z transform. So to plot our Z transform, this is how we can do the Z transform. So we'll just do it this way. Okay, so this place is called imaginary of Z. Imaginary of Z. This place is called real of Z. Real of Z. Real of Z. Okay. What it means is that this is the real axis, this is the imaginary what? Axis. Okay. So now sequence is that we will draw a circle that has a radius of what? A. So let me just draw that circle that has a radius of A. Okay, so this circle has a radius of A. But for ROC, normally we take the what? The modulus of the Z. So Z. So it has a radius of what? A. Inside this circle, you have what? Z less than what? A. Outside of this circle, you have what? Z greater than what? A. And my answer I got is what? Z greater than what? A. So that means that I must shade outside of the circle. Because I've told you that inside the circle, Z is less than what? A. Outside is Z greater than A. And what I got here is Z greater than what? A. So I must shade outside. Okay, so basically this is what I will get. Okay, so now what is going to happen is that I'm done, because now I have my Z transform and I have my ROC, so I can just write that Z transform x of Z, okay, which is equals to let's say Z of what? Of x of what? N, okay, is equals to what? Is equals to Z over Z minus A. Z over Z minus A. And the ROC is what? Greater than what? A. Okay. Or I can say that the Z transform A n U of what? N. Okay. A n U of what? N has a Z transform. If it undergoes Z transform, then you're going to get what? Z over what? Z minus what? A. And the ROC mod Z is greater than what? A. So this is the solution to the first question in this particular series. So let's solve the second one. So in the second one, we are given II. We are given x of n to be equals to minus a exponent n into u of n minus what? 1. This is what we are given. Okay, so first let's take a look at sorry, here is u. Okay, u. Okay, so this is what we are given. Okay, so first let's take a look at our unit step sequence. Okay, so first let's take a look at our unit step what? Sequence. Okay, let's take a look at our unit step sequence. Our unit step sequence, okay, which is what? Which is u of minus n minus what? 1. So now here in this particular sequence, what we have is that n is what? Equals to what? 1. Because n minus 1 means that n is equals to 1. But n is equals to 1 here will not start at the positive. Okay, it will start at the what? Negative. This axis is called n. Okay, all right. And here you have what? You have u of minus n minus what? 1 on the y-axis. Okay, which is the amplitude. Okay, so now here n minus 1 means that n is equals to 1. But we cannot start from 1 here because of this minus. Okay, so that 1 must be negative because of this minus. So I'll start from here. So everything will start from here. Okay, start from here. So okay, so here minus 1, minus 2, minus 3, minus 4, okay, and minus what? 5. Okay, so that is how it will be like. Okay, so now you see that, and then it will continue up to where? Infinity. Okay, so now but it will continue to what? Minus infinity. Okay, minus infinity. So now the Z transform x of what? Z, x of Z, okay, x of Z is going to be equals to summation from what? Infinity, n is equals to what? Minus what? Infinity, x of what? N into Z exponent minus what? N. Okay, so now you know that it's actually starting from what? Minus infinity to what? Minus 1. Minus infinity to what? Minus 1. Okay, so minus infinity to what? Minus 1. So I'll change it. So I'll make it x of what? Z is equals to what? N is equals to minus infinity to minus what? 1. Okay. And then x of n. What is x of n? X of n is this particular what? Sequence. Okay, x of n is this particular what? Sequence. So now that is what? Minus a into u, a exponent n, into u minus n minus what? 1. Okay, into z of what? Minus n. Okay, but I know that this u of what? Minus 1 minus n minus 1 is what? 1, because this place, a unit step sequence has a magnitude of what? 1. Okay, so that means that I can rewrite this thing I have as what? As x of z to be equals to summation n is equals to minus what? Infinity. This minus here, I can bring it outside. Okay, I can bring it here. And here is minus what? 1. Okay, so now here I'll have a exponent n. This u of minus 1 minus n, I told you that the value is what? 1. So it becomes what? 1. Okay, if I multiply the 1 with this one, then this is what I will get. Okay, minus what? N. Okay, this is what I will get. Alright. Okay, so basically, this is what I'm going to actually have. Okay, this is what I'm going to actually have. But let me try and change my summation. Okay, so that it will be very easy for me to deal with. Because if I'm going to sum something from infinity, I don't know infinity, so that will be very difficult for me to even start the signal at all. Okay, because it's starting from infinity to what? Minus 1. That will be difficult for me to deal with. So let me try and change my limit. Let me change my limit. So changing the limit, okay, put n to be equals to minus what? N. Put n to be equals to minus n. So that will make my signal is that now x of what? Z is equals to what? This minus, here it is. Okay, minus what? Z. Okay, so now I want to start my signal from what? From 1 to infinity. So n is equals to what? 1, and then it will go to what? Infinity. This limit, this summation will be very easy for me to deal with. It will be very easier for me to deal with. Okay, so now here you see that because I changed the summation, okay, from 1 to infinity, where there is n, I'll put minus n. So now it will become a exponent minus n, and this z exponent minus n will become what? Z exponent what? N. Okay, because minus minus n will become a positive n, and here will become what? Minus what? N. So this is what I'm going to have now. Okay, so now if I have this one, I can say that let it to be equals to what? Here is the minus sign. Okay, so this minus sign, okay, this minus sign, it came here, this minus sign is still here, and I've brought it here again. Okay, so now here n is equals to what? 1, and here is what? Infinity. Okay, so let's say that I'm going to have what? A exponent, let's say that a exponent what? Minus 1 into what? Z. Okay, all exponent what? N. Okay, so I can make my summation to be this way, because if you multiply n by a exponent minus 1, you get a exponent minus n. If you multiply n by what? Z, you get z exponent what? N. So it's the same thing. Okay, so it's the same thing. So now what I'm going to do is that I'm going to write the summation, okay, or the expansion for this particular summation that I have. It will start from what? 1, and then it will go to what? Infinity. So now x of what? Z is equals to, if I put 1 here, what do I get? I'll get a exponent minus 1 what? Z. Okay, now let me put 2 here. If I put 2 here, what will I get? Okay, if I put 2 there, what I will get is that I'll get a what? Z exponent what? A exponent what? Minus 1. Okay, and then it will go to what? A exponent minus 1z, and then what? 2. So I'll get what? A exponent minus 1 what? Z. Okay, and then here will be what? 2. Okay, and then I'll get, if I put 3 there, I'll get a exponent minus 1 what? Z. Okay, and I'll get what? 3. Okay, if I put 4 there, it will be what? a exponent minus 1 what z, and it will what 4. Okay, it will go up to what infinity. It will go up to infinity. All right. So now let's see. Okay. So now if I have this one, let me just simplify it a bit. Let me simplify it a bit. So if I'm simplifying this one, then it's going to be what I can bring. See what a minus 1 what z can come out because it's common in all of them. Okay, so if it comes out, what will I have? I'll have here to be 1. I'll have here to be 1. And then what will I have here? Here. Okay, here it will become a minus what? 1 what? Z. Okay, because that means that a exponent minus 1 times a exponent minus 1 will be a exponent minus what? 2. Because here you get a exponent minus 2. Then z exponent 1 times z exponent 1, you get z exponent 2. Here you get z exponent what? 2. So it's the same. Okay, then you come here. What do you get here? Okay, so over here, what you're going to get is you're going to get a minus 1 into what? Z. Okay, or what? Or squared. Okay, so that if you multiply a exponent minus 1 times a exponent what? Here, a exponent minus 1. Because of these two, it will be what? A exponent minus 1 times a exponent minus 2, which will be a exponent minus what? 3. And z exponent 1, here is z exponent 2. It will be z exponent what? 3. So it's the same. So similarly here, you get what? A exponent minus what? Z. Okay, into what? 3 plus up to what? Infinity. Okay, so now let's say that now let a minus 1 what? Z to be equals to what? X. If I do that, then my x of what? Z. My x of z is actually now equals to what? A exponent minus what? 1 what? Z. Okay, z, which is what? The same, which is into what? 1 plus what? X plus what? S squared plus what? S cubed. Okay, plus what? Up to infinity. And I told you that whenever you have any series like of this form, then the binomial expansion for it is going to be what? It's going to be like this. X of what? Z is equals to what? A exponent minus 1 what? Z. Okay, into what? Into here. If you have a series like this, I told you that the expansion is 1 minus what? X. Okay, into what? Minus 1. Okay, so this becomes what? The particular what? Series for this one. Okay, all right. So basically here it is same as what? The same as a exponent minus 1 what? Z. Okay, into what? 1 plus x plus s squared plus what? S cubed plus what? Up to infinity. Up to infinity. Okay. All right. So now this becomes my what? My z transform. This becomes my z transform. Okay. So now let me say that z transform is now equals to a minus 1 into what? Z into 1 minus what? X into minus 1. Okay, that's my z transform. And this is actually equals to what? A minus 1 into what? Z. Okay, over what? 1 minus what? X. Okay, 1 minus what? X, which is actually equals what? A minus what? 1 Z. Okay, over what? Over 1 minus a minus what? 1 what? Z. Because remember that I told you that this one, okay, from here, a minus 1 Z is what? X. Okay, so now if you should multiply through, okay, by a, if you should multiply through everything by a, then basically, sorry, please, here, you will recall that there was a minus sign that I have been forgetting. Okay, do you remember this place? Okay, do you remember this place? That there was a minus sign here. There was a minus sign here. You consider there was a minus sign here. This minus sign, we brought it here. Okay, so now it has to come here. Okay, it has to come here. It has to come here. It has to come here. Okay, it has to come here. It has to come here. It has to come here. It has to come what? Here. So now if I should multiply through by what? A. If I multiply through by a, what am I going to get? Okay, in that case, I will have what? Minus z over what? Over a. Okay, over a minus what? Z. Okay, so this becomes what? My Z transform. This becomes my Z transform. Now let's find the ROC. So now the ROC, okay, we know that ROC is always summation from infinity n to what? Minus infinity n is equals to, okay, x of what? N into what? Z exponent minus n. It should be less than what? Infinity. It should be less than infinity. So this is the ROC. So now this particular ROC that we have, what are we going to get from it? Okay, so now we know that here the summation, this summation, it can only reach infinity, okay, when x is less than what? 0. When x is less than 1. When x is less than what? 1. Okay, so that means that my ROC is such that x should be less than what? Should be less than 1. X should be less than 1. Okay, and I know that what is x? X is actually what? A exponent minus 1. Okay, x is actually a exponent what? Minus 1. Okay, x, what is the value for x? X is what? This one. Okay, x is this one. A exponent minus 1 z is equals to what? X. Okay, so minus 1 what? Z should be what? Less than what? 1. Okay, so now if I have this one, then what it means is that z over a is less than what? 1. Okay, then that means that z is what? Less than what? A. Okay, z is less than what? A. So for ROC, I'll write, okay, mod what? Z is less than what? A. Now let me draw the what? The Z plane for this one. Okay, so to draw the Z plane for this one, I'll just do this. Okay, this is the Z plane. Okay, so here is real of what? Z. Here is what? Imaginary of what? Z. Okay, so I'll draw a circle with radius A. A circle with radius A. So the circle has a radius equals to what? A. Now outside the circle is greater than A. Inside the circle is less than, sorry, outside the circle is greater than what? Z. Inside the circle, sorry, outside the circle, Z is greater than A. Inside the circle, Z is less than what? A. Here, Z is less than what? A. So it will be what? Inside the circle. Because outside the circle, okay, Z is greater than A. Inside the circle, Z is less than A. And here we have Z is less than what? A. Okay, so this becomes my what? ROC, my ROC. Okay, so this one is called what? Z what? Plane. Okay, so my final answer, what is my final answer? My final answer, what I can finally say is that if I have minus a exponent n into u of what? Minus n minus 1, okay, then if it undergoes what? Any kind of z transform, then what I should have is that I should have minus what? Z over what? A minus what? Z, okay, and then the ROC, Z should be less than what? A, okay. So this is the end of this particular question. I'll see you in the next class. This has been Dr. Barnes. Thank you.